All right, these are the graph log paper notes, like how to actually do log paper. You need a piece of loose leaf paper, a piece of graph paper, and a piece of log paper. Now, when you have the log paper out on your desk, there's, it looks really funny. It has all these really big and short lines. You want to make sure you're having the x-axis the correct direction. So, I'm going to go over this way really quick. That's not what I wanted you to do, screen. Thank you. When you look at it, that big gap at the bottom, that's supposed to be at the bottom of your paper. So make sure you're holding your graph paper correctly. If you want, you can label it right now bottom, top, so that way you know which direction to hold it. So if you look at the log paper, well, this way. And then you want to make sure that the bigger gap is at the bottom. Bigger gap is at the bottom. So make sure it matches what mine looks like, how there's a bigger gap, bigger gap, bigger gap, and the smaller gaps are on top. So make sure you're holding it correctly. If you need to move forward so that you can see, it's okay to do that. Alright, so what is log paper? Log paper is this really crazy paper that we use. We use log paper, so right on the top of your paper, log graph paper. Why do we use it? We use it for population and for money. Those are basically the two main reasons we use log paper, for population and money. Because the numbers can be so large and grow so fast. This lets us see exponential growth variations. So you should be writing this down. Log graph paper, why? For populations and money, to see variations, to see changes, Because if we look at, oh, that's not a good color. Because if we look at an exponential growth on regular paper, it'll just be a J curve. But on log paper, I'm going to draw it over here. On log paper, it could actually look like that. It'll actually show us the little variations. When we look at population size in England over our lifetime, it looks like exponential growth. You can't even see when the Black Plague happened. And that's what we'll be doing tomorrow, is actually doing the different major deaths, wars, and we call it Grim Reaper Day, because we look at wars and Black Plague and things like that. When we graph the Black Plague on log paper, you can actually see the dip where it happened. But if we do it on regular paper, you can't see it at all. So that's one of the main reasons that we use it. Alright, so log paper is set into groups or cycles. It's usually 3 or more. It's only more than 3 if you're dealing with a whole crap ton of data. We'll usually only do 3. And that's what's actually set on your paper. If you look at your paper, you'll see 3 distinct groups. We call them cycles. Each group is set into a cycle of 10. And we're going to do some examples of this today. After we don't have many notes on this, and then we'll do examples so that you guys can get the hang of it. We'll actually do an example with log paper and then the same example with graph paper so you can see the differences. You want these notes because the next 3 days in class we're going to be doing log paper, so you want to make sure that you have these so that you'll be able to reference them. So what I'm going to do is come around and do a spot check at the end of class to make sure you took these notes and you'll keep them. Because tomorrow we're going to do Grim Reaper's Revenge, to where you're going to need these because you're going to make a log graph. Alright, in between each cycle is a huge gap. Kind of like how in math they do like the railroad track gap. In population and math, or population and money data, we just represent the graph with the log paper. So when you see those big gaps in between the cycles, that's when it jumps numbers. Give you time to write that down. Alright, when you jump a gap, you need to increase by a factor. Whatever that factor is, it needs to be something that is distributed evenly. And it's dependent on your data. So if you need to jump from tens to millions, then great. If you need to jump from tens to thousands, then wonderful. You just need to make sure that it's the same throughout the whole graph. You can't just jump from thousands and then millions. And I'll show you what I mean. So like I said, when you jump to the next cycle, you need to jump a number set. So we'll do the example today of tens, hundreds, thousands. That's usually the most common. Or you can do one, tens, hundreds. What's nice is this data is usually whole numbers. You'll never have any like decimals or anything like that. I think that using log graph paper is almost easier because you don't have to like pick and choose what your y-axis is, because you know it has to be a set of numbers. You know it has to be either ones, tens, hundreds, or tens, hundreds, thousands, or thousands, millions, billions. So it makes it a lot easier to figure out your x-axis, because everything has to be done a certain way for log paper. The y-axis will usually end up being something like time. It's usually almost always time. Okay, so what do I mean by the number set? So for example, in the first cycle you could go 1 through 9, so you go by ones. Second cycle you go by tens, and third cycle you go by hundreds. And I'm going to show you what that looks like on the next slide as soon as everyone's done writing. I did these notes in class with second hour, so the pausing should be the correct time that you need to write these down. What's nice, too, of the people sitting in class is if you were totally lost on this, you could listen to this again, and it may help you. Alright, most of you are at the part where you're writing the cycles down. I'm going to move to the next slide. It has the cycles on the next slide. So on this slide, like I said, first cycle is 1 through 10. Second cycle is tens. And then third cycle would be hundreds. I just didn't write it out. If you want me to really, really crapfully write this out. So because I went 1 through 10, when you jump, you go back up to the... because I wrote it in ones, when you jump, you go tens, and then you go hundreds. So 200, 300, 400. Oh my gosh, my board is not calibrated. So annoying. 7, 8, 9, and 1,000. And that makes it really easy, because then if I had 4 cycles, I would have to go from thousands to either 10,000s or 100,000s or millions. Like, you just keep tacking a 0 onto the end of it, which is really nice, because then you don't need to figure out, okay, do I need to go by 5? Do I need to go by 2s? It's always by 10s. It's always by 10s. Alright, so looking at the data, this is the turkey population. You can see, when they give it to you in a graph like this, yes, most people look at it as a T-chart. Scientists, we see it as like an actual graph. It's a T-chart with a box around it. Amazing. Freshmen were really confused about this last week. So when you're looking at it, first one's X, second one's Y. I'm going over basic graphing skills. You should know this. It's why I'm not covering it very much, because you should know how to graph. So X-axis, Y-axis. Good Lord, you should know that. So population is going to always be on the Y-axis. Like I said, time will be on the X, so population. Like I said, you should know how to graph. So you are expected to have titles. You are expected to have labels. A key, if necessary. That's all stuff that I grade when I do graphs. Graphing is a huge part to science. Huge. Science and math go hand in hand. In order to get my science degree, I had to take calculus. So graph title is going to be turkey. Population. Don't just put turkey, because then what I think you're doing is like counting the number of turkeys people bought at Thanksgiving. A lot of turkeys. But you need to make sure that you label everything correctly. So then this is going to be the year. What I like about this paper is they kind of give you little dividers. So there's 1, 2, 3, 4, 5. Oh, sorry, you can't see where I'm pointing in the video. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So maybe I'll go 1 in, and that should help. So then on your paper, go ahead and you should be writing this down in your paper. We're going to do this graph. So yeah, on your log paper. So 2000, and it goes up by 1 year to 12. Okay. So I went 1, 2, 3 in a year. 1, 2, 3, and 2001, 2002, 2004. Oh crap. 2005. Now notice that I'm writing on the line. When you get so far down, you'll notice your numbers increase by so much that you're not going to have any plots down near this first cycle. So if it helps you for space and writing everything out, then you can write on the line. 2008, 2009, 2010, 2011, 2012. What some people like to do, because they want to know where their points are, is that they will actually draw them out. But you don't have to. I love that pen tool. Yes?
I can honestly not tell where you're like putting the points.
I was putting the points every 3 lines. So I counted 1, oh my gosh.
Every 4?
Yeah, every 4, sorry. I had 3 lines in between each one. So so this is my 0 line. So I had 1, 2, 3, and then I made a year. 1, 2, 3, and I made a year. 1, 2, 3, and I made a year. So I had 3 lines in between each one. Yeah, handwriting's not the best. That's why on the y-axis I typed it in beforehand so that you could actually see it. Okay, so while you guys are doing that, plotting this, honestly, you guys should know this. You really should. It's plotting. You have the year 2066, holy crap, tons. That's a lot of numbers. So is our graph even made correctly? No, it's not. What? So what's the lowest number? 3 what? Almost 4. This one, right? 1, 2, 3, yeah. So what's that number? 2 what? I think that's billion? 2,150,850,520. Yeah, so that'd be 2 million. Yeah, million. So then the easy way to end up doing this is you go by millions. You just write this cute little word right here that says millions. Holy cow, that changes all these numbers. That way you don't have to write all the zeros. So, yeah, that's a really, really bad millions. We're going to go like this. So by putting in millions, you are effectively saying all of these numbers are millions, no matter what they might say. Bigger eraser. So that way, this is 1 million, 2 million, 3 million, 20 million, 200 million. So that way it covers all of our numbers. So the first one in 2000, we had, oh no, our lowest number is 66,000. Can you tell that it's been a year since I've done this? Yeah, it's been way too long since I've done this graph. Alright, so, back to basics really quick. How do you know what to do your x-axis in? Sorry, hang on a second. You need to look at your smallest number. So we have, in 2000 we had 65,000. So you were right on the thousand part of it. So let's change these to thousands. Alright, so if we have 65,000 is our smallest number, then what we should do is not start with ones. So let's get rid of this. No, I didn't want to get rid of all of you. Just some of you. Yeah, I know you already wrote it on your paper second hour, and it's fine. I realize it's going to be screwed up. Just leave it. We're going to be doing more practice later. It's not a big deal. Nope, didn't want to do that. Crap. Alright, so we're taking all these numbers and dropping them down so that we start with tens. You don't have to erase it. I know that your graph's going to be screwed up because I'm awesome and I screwed up. Alright, so why did I drop it down? Because we didn't start until in 2000 it's 65,000. So there weren't even any single thousands. There weren't like 5,000 or 6,000. So I took out the singles. You got to figure out whether or not you're doing tens, hundreds, or thousands. So 65,000 for the year 2000 is going to be about here-ish. So I'm at the year 2000, and it's 65,000. This is in thousands, so this is 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, 65,000. Having this on the y-axis changes everything, because that lets you know how many zeros are after it. Okay, so then in 2001, I'm at 70,000. That's why I like having the lines there, because I don't have to like constantly look down. I can just look for the next purple line. And then we're 79, and then 170,000. So this would be 200. Oops. So 170,000 would be about here-ish. And then we have 379,000 for 2004. So there's 300, 400,000, 500,000, 600,000, 700,000, 800,000, 900,000, a million, 100,000. A thousand of a million's a billion. So it'd be a billion. You'll be okay. Breathe. We'll get practice with this. I just want to show you how to set it up. So, yeah, you add a zero each time you go up. So that these are in tens of thousands, and then this next group, this top group here, will end up being in millions. But we're adding, for the sake of log paper, you just add a zero. So that's why I always make this note here. So this would be 2,000 million. 2,000 thousand, 2 million. So 3 million, 4 million, 5, 6, 7, 8, 9, 10. Alright, so 2000, where I'm at, 5 is... No, I'm at 4, 2004. That's supposed to be a 4. 379,000, so that's about here-ish. And then I've got 400-ish, 770, and then 971, and then I go 1 million, 2 million, 3 million, 3 million, 4 million. So 1 million, 2 million, wow, it's awkward when the fan shuts off. 3 million, 4 million. And I left off a number. Oops. My bad. That's probably why it looks weird. So connecting the wonderful dots. No, I just want to click the line. Just give me my line. There we go. That is a J curve on graph paper. But you can see the gradual increases and decreases. You can see where the population leveled out, and then you had either a lot less people dying, or you had a lot more birth rates. Like here, this leveling out could have been a war, so that there were equal number of births and deaths. So this can tell you different population changes. Okay, is this confusing? Yes. Will you have lots of practice? Yes. By the end of the week, should you know this? Yes. Should you know it by the end of today? Probably not. It's different. It's weird. The paper is not even. It bugs the OCD people. It's so much fun that it bugs the OCD people. So, what should you know today? On log paper, the bigger gap goes at the bottom. The weird lines are the y-axis. There are 3 cycles on a paper. So when you look at it, you have the first cycle, the second cycle, and the third cycle. Each cycle should be in a group of tens. So in this case, we did tens, hundreds, thousands. But because our numbers were so large, we labeled our y-axis in thousands, so that we had tens of thousands, hundreds of thousands, and then millions. It's all about adding the zeros. That's why I think this is easier, is because you don't have to choose if you go by ones or twos or fives. It's always tens. It's just, what do you start with? Ones, tens, hundreds, or thousands. So, yeah, I know I missed 2003. Oops. It wasn't an important year anyway. It was only the year I graduated. No big deal. So knowing how to hold your log paper is important, and knowing that it's in 3 cycles and they go by tens. That right there means you have accomplished the goal for today. All right. Is your brain about to explode? Yeah, I'm sorry. If it makes you feel better, we're going to go to the regular paper now. Alright, we will go back to this after I finish this video. I just want to finish this video like within the next 2 minutes. So real quick, what I'm going to have you do, because you should know how to do this already, and I'm talking mostly to the people that are listening to this through YouTube, is when you do regular graph paper, you always want to leave some space for yourself. Again, we're going to have year, we'll have population in thousands. I'm just writing this fast so that we can get through it. And then we can go 2000, 2001, 2002, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then for the year, we start with 65,000. So, and this is why regular graph paper sucks. It's because you have to go to 4 million in some way, but you have to start with like 60,000. So 60,000. So now you have to figure out, how do I go from 60,000 to 4 million in a equal amount of time? It kind of sucks. It's kind of horrible. So even if we go by, let's say, 10,000, that's 60,000, 70,000, 80,000, 90,000, 100,000, 10, 20, 30, 140. You're not going to make it to 4 million. You have way too many numbers to go. This is why I don't like regular paper. Log paper makes so much more sense to me. So help me out. What's the easiest way to be able to go from 65,000 to 4 million? Huh? So we have 1 million, 2 million, 3 million, 4 million, 100,000s. Probably be easier to go by 100,000s. So if you go 100,000, 200,000, 300,000. I know I'm not doing this very evenly. 400,000, 500,000, 600,000, 700,000, 800,000, 900,000, a million. But the thing is that you can't just like go. Yeah, you can't just go 1 million, 2 million, 3 million. You still have to keep going by the 100,000s. So you're still not even going to make it all the way up. So even if we stop there to plot it, you have, so 65,000, that's still somewhere down there. Oop, let me change to the green. 70,000, still somewhere down there. 80. Hey, 170, we're actually like up on a number. 379. Can someone read the next number to me? 469. So that would be like there-ish. And then what's after 460? 770. I keep having to like, for those of you that can't see my eyes, I keep having to like look up here for the number. Oops. I keep having to look up here for the number and then look over for the dot and look down and make sure like I'm all rah. This is why I don't like regular paper. So, Devin, you need to stop talking. So then for 2009, or 2008, excuse me, you'll have a million, which would be somewhere up there. So if I just plot just this, you can see it's not really, actually let me do that over. I try to actually connect the dots. It's not really varying too much. Because then if we keep going, because we have so much distance in here, it's just going to keep going straight up. You're not going to see any of this dip because there's such a big gap in between the set of numbers, because we don't have the gaps in the cycles like we do in log paper. This is why we use it for population, because we can actually see population changes, death and birth. We can actually graph different populations and circle where wars happen or where disease happened, and that's what we're going to do tomorrow. Is you're going to make the graph and you're going to circle where the Black Plague was and everything else. That's why we call it Grim Reaper's Revenge. And this is why graph paper is not accurate for population or money. So log paper is not accurate representation if you're looking at population or money. If you're looking at really any other data, it's going to be fine. But for population and money, it's not going to show you these subtle changes, especially with money. It's how a lot of people screw things up, is they'll just plot it and, oh, I'm fine, when really it's like, oh, no, I'm actually losing money. You just can't see it because it's such a gradual change. All right, if you have questions, make sure that you come and see me. Like I said, we're going to be practicing these next couple of days.